let me see in some of my videos the utilization of 3 coils. Here I have 3 coils again. I have this set up so that I can adjust this is my primary, this is my first secondary, this is my tertiary. And what I have here is off of the primary and earth ground, off of the opposite end of the primary I go through a capacitor into one end of the tertiary. From the secondary, off of one side, I have a 1N4148. Off of the other side of the secondary, I have an AV plug and this red lead, which you see fully illuminated. Now, off of the AV plug, I also have a clip lead, which is laying here to balance the impedance. Now, this is not an antenna, and let me demonstrate that. If I move my hand in the area, the impedance of this arrangement is so extremely high, I'm not adding signal to it, I'm actually killing the whole operation. What we have here is an oscillation going on between these 3 coils in the earth ground. Now let me demonstrate something to you. Let me grab a probe and I'll show you. Here's another AV plug hooked to another red lead. Let me show you that there's absolutely no signal here at all off of this ground connection. There's no signal coming in here whatsoever. Okay, you can see there's nothing coming out of that red lead. And let me move down here to this end of the secondary coil. You see we have a little bit of light, and you can see how it impacts the output of the output lead. It actually kills the operation. So we'll go to the other side of the diode. You can see we have the same condition. It will kill the output lead, and we have very little. If you can see that, there's hardly any light at all. And here again you can see we have a little bit more light than at this end. So you see that we have feedback coming back from the tertiary coil through this capacitor to the primary, which is indeed building up the signal going back into the secondary, going through this diode arrangement. The centering of the coils is extremely important. As you see, I've slotted the panel that I have them mounted on. The reason for that is this is not similar to the eccentric transformer which you can find on energetic form. It doesn't follow the 2R rule. Actually, it's more like 2.8, 2.85. But you have to adjust this. There's no way you can calculate this. That's why I have this sliding slot in here, so that once I choose the frequency of my coils, all of these coils have been adjusted to be exactly the same or as close as I can get them. And that's done by picking my first coil and then removing wire from the additional coils to bring them down into the same self-resonant point. What you'll see here, though, is that the actual self-resonant point turns out to be around 19 megahertz, but this thing is actually oscillating at 14.3. Another thing to be aware of is that when you do this, the impedance is so very, very high that you have to be sure, and that's what I've done here on this table, is removed it from other objects, because that will change the tuning of your coils. Even the coils being in proximity to one another has affected the self-resonant frequency. That's why we're oscillating lower than what the individual coil would be. But this gives you a pretty good idea that you can get some remarkable gain out of just coils. No transistors, one diode, one capacitor, 3 coils, and an earth ground. And I do have a video, of course. I think I should probably put it on here for you. We can drive 2 white LEDs off of this, surprisingly enough. But anyway, this will give you a pretty good picture. Disregard this coil. I painted him black. He has some electrical tape on him. This guy has had some varnish put on him. They're kind of rough-looking coils. This is a standard L3 here, 1N4148. That capacitor is used for tuning the frequency, the overtone that I want for it to go into oscillation. So anyway, I thought I'd throw that up here. It's another example of what you can do at resonance and how you can use a couple of parts to actually light an LED.